Okay, we're going to just do a little bit more organic. So we are going to talk a little bit more here about organic, and then I'm pretty much out of organic, I think, at that point. All right, so last time we talked about organic chemistry, which we all agreed upon was the study of carbon. So basic organic molecules, as we talked about, is our carbon to carbon connections, and again, our hydrogens that are attached to it. The idea that we talked about, a couple of things about hybridization. Remember that hybridization basically is counted through electron pairs. So for example, here we would count this one, 1, 2, 3, and 4. So 1, 2, 3, and 4, which is our sp3 hybridization. Alkanes, which are single bonded, typically will have that sp3 hybridization. When we do add some double bonds into the mix here, we also sacrifice some hydrogens, as we talked about, on a couple of the carbons there to allow room for it. That's going to give me 1, 2, and 3 electron pairs, which would give me sp2 hybridization happening there. And also when we add our triple bond here with an S, no, let's try that again. Let's try triple bond here with a carbon. Again, we'll lose a couple more hydrogens along the way. And remember, double bonds, triple bonds count as effectively 1 electron pair. So that would be 1 electron pair, 2 electron pairs, which would get us to S and P hybridized. Once again, because carbon is the basis of most organic molecules, you don't really get into that kind of the expanded octets for it. So your sp, sp2, sp3 is usually the ones that you will see. We talked also about some different types of formulas. This is what is sometimes referred to as the expanded structural formula. And that's basically a Lewis structure where you draw out all the bonds to the hydrogens. There's also condensed, which is used a lot in organic chemistry, which looks something like this, where you do not draw out the hydrogens. And there's also line structure, where pretty much you don't draw out anything, but just random lines going up and down in most cases. Again, at each of these points are carbons along the way here. And the idea is carbon must obey the octet rule because it's group number 2 and that second energy level, which means that it does need 4 bonds when it's all said and done. And we usually will fill in with hydrogens along the way to get the 4 bonds. Now, there are different types of organic molecules, as we talked about, and a lot of what makes something a specific type of organic molecule are functional groups, and that's sort of the part of the organic molecule that sort of makes it that type of organic compound. Like, for example, alkanes have all single bonds. If you got a double bond there, those are alkenes. If you have a triple bond, those are alkynes. If you have an OH group, that's an alcohol. You have a carbon, carbon, carbon with a double bond in the middle. That's our friend, the ketone. Carbon, double bond, oxygen, hydrogen. That's an aldehyde. Carbon, oxygen, carbon. It's an ether. Carbon, oxygen, double bond to an oxygen is an ester. Also to a carbon on the back end of that. We also have things like our carboxylic acid. I'm just trying to see if I remember them all, so I'm just going off the top of my head here. That's a carboxylic acid. We have nitrogen-containing groups, which are amines. And we also have our friend there, carbon, oxygen with a nitrogen-containing group, which is our amides. Not to forget our sulfur-containing group, which is our thiols. I think I got most of them there. I'll throw benzene in there for our aromatics there. All right. So depending on sort of any of these sort of functional groups that you may have, the organic molecule will have some different properties. So as we talked about, so your basic alkanes, alkenes, and those sort of hydrocarbons which are just carbons and hydrogens, are pretty much nonpolar, which means they don't do really well with water. But as you start getting some of these groups that do contain groups like the OH group in there or things like that, it does give them the ability to hydrogen bond and be a little bit more soluble in water, including with our amines there, can also be soluble. Now, we talked about naming alkanes, which are these carbon-carbon single bonded guys. And as I mentioned, the first 10 alkanes typically are really important because a lot of things are named based off of them. And they do have the general formula of CnH2n plus 2. And again, if we have one carbon, that is going to give us 4 hydrogens, and that is methane. If we have 2 carbons, that'll give us 6 hydrogens, which is ethane. 3 carbons will give us 8 hydrogens. That's going to be propane. 4 carbons will give us 10 hydrogens, which will be butane. 5 carbons, 12 hydrogens gives us pentane. 6 carbons, 14 hydrogens gives us hexane. And then we have our 7 and 16 gives us heptane. 8 and 18 is octane, and 9 and 20 here is nonane, and lastly 10 here gives us 22 hydrogens, and that's going to be decane. So a lot of names do come back to these, the way other organic molecules are named. Also, groups that are attached, which are sometimes referred to as alkyl groups, are also based off of these guys. They typically will have one less hydrogen. Yes, they will. One less hydrogen than the alkane. And that is typically your alkyl group, which is sort of a carbon-based group. And having one less hydrogen, again, gives it the opportunity to bind into the main part of the chain without having too many bonds. So, for example, here, if we had a CH3, that is a methyl group, which is really based off of methane, which has 4 hydrogens. Obviously, again, missing one of those there to allow it to attach in. Again, we kind of drop the last part of the name and replace it with YL. Any questions on that stuff there? So we also talked about the way of naming everything, and essentially when you go to name alkanes, we always look for the longest carbon chain. And with alkanes, that does not have to be, or with anything really, it doesn't always have to be the straightest that you see, but it can go straight, go up, and go over. The only deal is when you're counting, you just can't go backwards, as we talked about. So you kind of have to go one way till you hit a dead end, and that will give you the longest carbon chain, which is sort of like the base of your name. And then anything that's really attached that's not part of the chain, anything that's not part of it is considered really like a group. And if it's a carbon group, it'll be an alkyl group, which will have a name very similar, again, like methyl, ethyl, propyl type of groups. You then want to ID those groups, obviously. And you want to then number the longest carbon chain. So when you number the longest carbon chain for alkanes, it is the groups that get the priority. And you want to make sure that you give the groups the smallest number possible. Now, when you move on from alkanes, for example, what happens in terms of numbering and the priority of numbering, it actually switches over to really more the functional group. So, for example, if you had an alcohol, you would give the alcohol the priority, the OH group, the priority in terms of numbering, and you would want that to have the smallest number. If you had an alkene that has a double bond or an alkyne that has a triple bond, you would then give the priority to that double bond or triple bond in terms of the numbering. But in alkanes, sort of, we give the priority to the groups that are attached in that case. Once you have all that, we do sort of name everything groups first in alphabetical order. Then really the base of the name. We also talked about a couple of things like we always use a dash between a number and a letter, or even a letter and a number. So if you're kind of going this way, we use dashes. And also there are situations where you could end up with two numbers. I think we did one towards the end last time that you would use a comma between the two numbers. And you do have to give the location of all the groups that are attached, even again, if they are attached on the same carbon, you have to give the number twice, the same number twice when you're going to name it. So naming is really all about sort of location of where everything's attached. Any questions on that there? So again, those alkyl groups are really our alkanes minus that one hydrogen, and we do put the YL on it, as we can see here and as we talked about. That's methane, has no way to attach in because it has 4 bonds. So by losing that hydrogen gives it a place to attach and becomes a methyl group. Same thing here with our ethane. If we take off any of those hydrogens, by the way, you can take off any of those hydrogens, they're all equivalent hydrogens. And you will have an ethyl group. So here's some of those kind of normal alkyl groups: methyl, ethyl, propyl, butyl, pentyl, hexyl. They're all pretty much the exact same thing as the alkanes, less 1 hydrogen in each of them. We also talked about that some groups do have our branch chains and also have some special names. A very common one, again, is the one we talked about, I think, last time, which is the isopropyl group. And the difference between a propyl group and an isopropyl group is where it attaches in. A propyl group, or sometimes referred to as an N-propyl group, is a propyl group where it attaches in through a primary carbon, which we also talked about. Primary carbon is a carbon that is attached to one other carbon directly. The isopropyl group, though, attaches through the secondary carbon, which is right here. That carbon is attached to 1 and 2 carbons directly to it, which makes it a secondary carbon, and that's isopropyl. We also have an isobutyl group as well. There's 4 total carbons in this group, which is why it's based off of butane, but the attachment here is coming through a secondary carbon there in the middle, which gives it our isobutyl. Sec-butyl as well. And then also T-butyl, which is tertiary, and that is attached to our tertiary carbon here, which is basically the carbon that's attached directly to 3 carbons. So occasionally in organic chemistry, you'll sometimes run across some groups that have special names, and their historical names, they're still used today. And some of them are based on where the connection happens in terms of the carbon. Is it primary, secondary, or tertiary sort of carbon that happens? Any questions on that there? All right, so I think we did though. Look at those here. Kind of talked about that. The other thing that we also talked about was the idea that if you do have more than one of the same group in a particular molecule, we also do use prefixes for that group. So if we had 2 methyls, like we might have done an example last time, you would put dimethyl. And if you have 3, it would be tri, or 4 would be tetra. So it is possible to have multiple groups in the same compound. Those groups do not have to be on the same carbon to use the prefix. It just means in this whole entire compound, they could be on the same carbon, they could be on different carbons, but we'll use a prefix to indicate how many that you have. So like this one here, there are 2 methyl groups. They're on different carbons, but that would get the dimethyl. Here we would look for the longest carbon chain, which is box. It looks like 1, 2, 3, 4, 5, and 6. So the base of this name would be hexane. We have a methyl here and a methyl here, which would give us a dimethyl. And again, we would need to give the numbers, which in this case would be a 2, 3 dimethyl hexane in this case. Once again, we have the comma separating the 2 numbers and the dash between the number and the letter that is happening there. Any questions on that one there? All right, so we alphabetized it, ignoring prefixes, all these fun things. dashes, comma, right? All right, so let's take a look at some here. This is good looking here. All right, why don't you do these? There's three of them. Why not? Why don't you name these three things? Gonna write with this pen. That seemed like the wrong pin there to write with. Like, wow, nothing's showing up. All right, let's take a looky here and see. We'll go with the longest carbon chain here, number one. I think we go straight across here. 1, 2, 3, 4, 5, and 6. We can also get 6 by going straight across and then upwards that way, right about there. And you can get 6 by starting this way and going up. So there's multiple ways you can get to 6. I don't think there's anything more than 6. So might as well just take the straightest 6 that we got there. And that looks like 6 is going to be hexane as the base of our name, since it does have 6 carbons. That means we also have a couple groups hanging out there. We got this guy here, which is a group, and we got this 2 carbon group here. So that's going to be a methyl group, which is a 1 carbon group based off of methane. That'll be an ethyl group, which is obviously a 2 carbon group based off there of ethane. We do need to number our chain. Once again here, we do want to give the groups, in this case, the smallest number. You can maybe see it, but if you go right to left here, 1, 2, 3, 4, 5, and 6, that's going to give those groups numbers 2 and 4. If you went the other way, you're looking at it being like carbon number 3 and 5, which is obviously a larger set of numbers. So we would want to go in this direction here. And putting all that together, that means that this is going to be 2-methyl. That will be 3-ethyl. We do want to go alphabetical first. So we're going to go with 3-ethyl dash 2-methyl. And then we'll slap the hexane there at the end. Yeah. Any question on that name there? Look, yeah. Because it should be 4. But other than that reason, I look clearly at the wrong number. Thank you. We'll cut that out too. It's gonna be like hello, goodbye video later today. All right, so 4-ethyl, and that would be 4. Thank you. Yeah, should be 4. Obviously, it's in that number 4. Other questions all out there. All right, take a look at the guy number 2. I'm thinking probably our longest here is going to be right about here. That's 3, 4, 5, 6, 7, I think, right about there. Really, your only other option would be to start here and go up, which would give you 4. You could also start here, which would give you 1, 2, 3, 4, and then go up, which would be 5, which obviously is less than what we're looking at. So that's 5 packed there. So that's going to be heptane as the base of our name. In this case, we have just 1 group hanging off of it, which would be a methyl group. And numbering here, if we go 1, 2, and 3, that seems a lot smaller than if we started here, which obviously it would be more than 3. So we would want a number in this direction. And I'll try to get the right number here. So I was going to go with 3-methyl here, heptane. Any questions on that name there? Lastly here, longest carbon chain is I'm gonna go with 8. Yeah. 1, 2, 3, 4, 5, 6, 7, and 8. Right over through, like right through that, we're move right there. So once again, it's not always the straightest. You do want to kind of check all your options, but I think that's going to be a winner on this one, which is going to come through there. So in this case, that means 8 is going to be octane as the base of the name. We then would have some stuff attached there, and it looks like we have a 2 carbon group hanging there and a 1 carbon group right there, which is going to be our ethyl. based off of ethane, and our methyl group there based off of methane. And numbering here, I'm thinking maybe we'll start up here on top. 1, 2, and 3, 4, and 5. So that gives us a groups at 3 and 5 going that way. If we want the other way, 1, 2, 3, 4, and 5, and 6. So that's like a 4 and a 6, I think, going the other way. And again, it is as simple as 3 is smaller than 4. So we are going to number starting up on top there and coming down. And that means that our methyl will be at carbon number 3. And our ethyl will be at carbon 5 there. So once again, alphabetically here, we're going to go with the ethyl first. So 5 ethyl. Maybe try to squeeze that in there. 3 methyl. I'll just go above it. And we'll go octane. Yeah. A question on any of those names? One with names. I like it. I was going to say that was all 1 on the bottom. That looked like a fun one, but it's not. All right. I don't know. Let's try B. I just like the way it looks. It's the same name. I don't know. It's the same name. I feel like it's the same one. I feel like maybe that's why I liked it so much. No draw one. All right. And just, here, I'm just going to do squiggly lines. Then I'm going to put a line there. I'm going to put a line there. I'm going to put a BR there. And then I'm going to also squiggle over here. I don't know. It is. Yeah, we'll just put a couple extra lines this way. Really, that's like highlight the middle part there. All right, let's take a look at my bad piece of art here and see what we got going on here. Gosh, I feel like 9 is the winner there. Yeah, maybe. We got like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Could also get 9, I think, if you started here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you kind of went upwards, and believe it or not, I don't know how I drew it this way, but I think you could also get 9 if you went 1, 2, 3, 4, 5, 6, 7, and 8, 9 coming up that way. Now I feel seeing more artwork there as it's got more lines on it. All right, so I think 9 is a winner. A couple of different ways I think you could get to 9. So we'll go with 9 as the longest there. So that's going to be like a no name, maybe. We got a couple things hanging off. That is a bromine group, which is a bromol group. We have a lonely tilted line there, which is a carbon at the end of that, which should be a methyl group, I hope. And I think we got 1, 2, and 3 carbon group kind of hanging off right about there. 3 carbons is propane, and that would be a propyl group, I think. Yeah. Any questions on any of that identification of my squiggly lines? So we want a number. I think you can probably see it. Obviously, if we go left to right here, we're going to hit some smaller numbers than if we went right to left. So that's going to be a 1, 2, 3, 4, 5, 6, 7, 8, and 9. That means my methyl there, carbon number 2, my propyl at carbon number 4, and my bromol at carbon number 5. So that's a little alphabetical situation here, right? So I'm gonna go with B first. I got that part. I'm gonna leave the rest of the alphabet to you. So that's gonna be M before P, I think. So that's gonna be methyl. And that's gonna be for propyl. And a little no name at the end of that. That just rolls off the tongue, I think. And I think that's what I'm going to call the artwork here. Why I sell it as 5-bromyl, 2-methyl, 4-propyl, no name. Just like they drew it up, I suppose. Yes. Any questions on any of that there? Perhaps. Speaking of drawing, why don't we get some practice? Why don't we draw some of these? There it is. It's almost like I was reading your mind. I know. All right, draw the condensed formula. Hey, why don't you also draw the line structure as well, just for fun? There you go. So remember when we do draws, we talked last time, you want to work backwards. Yes. Okay, so let's take a look at to do these again, always want to kind of start backwards when you have the names. So butane tells us basically how many carbons, and that is a 4-pack, I think. And again here, I would just start with the carbons. You can number them whichever way you want to go since you're drawing them. So I'm gonna call that carbon number 1 for me. That means that carbon number 2 and 3, there are methyl groups, which is what the dimethyl means. So carbon 2 for me and 3. Now, at that point, we pretty much took care of all the name. All this left is to get carbon 4 bonds with hydrogen. So 3 there, needs 1 there, and 3 there. That would be the condensed formula. If you're doing the line structure, you could kind of do the same thing. Just start with your 4 carbons. And again, just lay up your groups attached there. Again, that would be obviously carbon number 1 for me, starting right about there. Any questions on that one? Although now it looks like a methyl group just attached there, but I'll get rid of my number. Yeah. It does. It does. And in this case, alkanes are single bonded, which means they have freedom to rotate around the axis. So you can put them on top or not. Actually, when you get into double bonds and triple bonds and alkanes, it actually locks that bond into place, and they can't have that free rotation. And that does give you the like cis and trans isomers we talked about a little bit there. And that's when those develop and stuff like that. But you could actually draw them up or down. It doesn't really matter in this case. Yeah. Other questions? All right. So starting here with my eraser, let's try something that writes maybe. Here we go. Whoa, heptane. Heptane is 7. That's a lot of carbons. All right, 1, 2, 3, 4, 5. We'll go this way. 6. That was 7 that way. Hopefully that's 7. I hope. I got like this bad glare like right on the screen. I can't even see it. All right, so that's 7. And again, I'm going to start with carbon 1 way over here, which means that carbon number 2, I do have a methyl, which would be a 1 carbon group. Carbon number 3, I have an ethyl. I'm going to go down because it seems more spacious and roomy down there. There we go. And again, here we're just going to fill in our hydrogens to get everybody to 4. So they have 2 lines, just needs 1, just needs 1, just needs 1, and 3 there. Again, if you're going to do a line action there, 2, 3, 4, 5, 6, 7, I hope. And at number 2 would be a methyl, which would just be a line. And then at carbon number 3, a little ethyl sort of action happening. Any question on that one there? Lastly, we have pentane, which means 5 carbons. And carbon number 1 on the left here for me. So number 2 has a chlorine group, which is a Cl. And carbon number 4, which should be here, would be a methyl group. So that would look something like that. Once again, you're going to fill in with hydrogens to get the 4 bonds. So it has 1 line, which would give us 3 hydrogens. Only 1 hydrogen needed there. 2 hydrogens there. 1 there and 3 there. And same deal. You just start with your 5. 1, 2, 3, 4, and 5. And again, at number 2 here, we do need to put the Cl, otherwise it's a methyl group if you just put the line. And number 4, though, we could just put the line. Any questions on how to draw alkanes, which I would say is probably the easiest of the bunch, even though sometimes it makes it seem like it's harder. You just draw what it says, basically. Yes. Any questions on any of that stuff there? Well, that feels good about organic, doesn't it?